So hello guys, today we are going to solve a Leetcode question that goes by the name contains duplicate 2. It's an ET level question. The question number is 219. Okay. So first we'll try to read the problem statement and then we'll go on to the solution. Okay. So what does the problem statement says? Given an integer array nums and an integer array integer k, return true if there are two distinct indices I and j in the array such that nums of I equal to nums of j and absolute of I minus j less than equal to k. Okay, so I'll just first write what I am given with. I am given with a nums array and an integer k Okay, what I have to find is you have to return true. You have to return true if there are two distinct indices such that two condition follows I nums of I equals to nums of j. This condition should follow, and absolute of I minus j less than equal to k. Okay, basically if I just try to take the first test case and explain you 1 2 3 1 k is equal to 3 1 2 3 1 and k is equal to 3. In this case k is equal to 3. Okay, so if I just try to iterate this array, what I am said is I have to compare. Basically I have to see that I have to select two indices I and j such that the both of these indices are equal. Basically two conditions have to be followed. First is nums of I should be equal to nums of j. And second condition is absolute of I minus j should be less than equal to k. So if nums of I is equal to nums of j, we have to just see in the whole array what we have to see. We have to just see the equal elements. And we will get a solution. Equal elements. What I'll do is, so if we have to see the equal elements, so this is my first condition defined. What does my second condition says? Basically the index between any two occurrences of the same element, basically if one is here and one is here and my k is given as 3, if this is my indexing 0 1 2 3, so if the distance like 3 minus 0 if 3 minus 0 equal to k then I'll return true. Okay, so then I'll return true. So 3 minus 0 is equal to k, 3 minus 0 is equal to 3, then I'll return true, else I'll return false. Basically if I'm just given with this example, 1 1 2 2 3 and then 4 3. Okay, and my k is given as 3, or my k is given as 2. Okay, I'll just mark as indexes 0 1 2 3 4 5 6. Okay, so what I have to see, I have to just see the equal numbers. So just the equal numbers, k is equal to 2, so equal numbers should be in proximity of, there should be at least one number that has a difference that are equal and lies in between, like, and this condition also satisfies. Okay, so any of the two numbers which satisfy this condition, if there are any two numbers that satisfy this condition, so I simply return true. So if I see in the first case, okay, so 1 minus 0 is equal to 1 and that is less than equal to 2, so I'll return true. If suppose 2 is here and then then 10 is here, 20 is here. Okay, so 3 and 4 3 is here. Okay, so if 3 is here and 3 is here, I can simply compare these indexes. Okay, and if the difference is less than equal to k, I can simply return it. Okay, so what is my brute force solution? What can be my brute force solution? If I just try to see the brute force solution, I'll take the first test case and explain you 1 2 3 1 and k is equal to 3. What is my first condition? That the ith number should be equal to the jth number, and absolute of I minus j should be less than equal to k. So what can be my brute force solution? Basically, I can start with this. I can start with this, and I can see to all the indexes. Basically, if I fix my I here, I can put my j here, here, or here. And if I get this condition that both of these are equal, both of these are equal, so my first condition would be satisfied. First condition would be satisfied. Now I'll just check for this condition for all those cases. For all those cases, basically for this, for this, for this. So here the first condition is satisfied. Here the first condition is satisfied, 1 with 1. Now I'll just compare the indexes. So 3 minus 0 is equal to 3, that is less than equal to k. So in this case, the condition is satisfied. Condition is satisfied. Condition satisfied. Okay, condition satisfied. So this can be my brute force solution. Similarly, if there was a 2, if there was a 2 here, I will just check for all the numbers. Here my condition becomes true. I'll just check for a difference between the indexes. Okay, and I'll get the solution. I'll get the solution. Okay, but how can I optimize this solution? If I just try to see the time complexity of this solution, this solution, it has a time complexity of n square. Why? Because like for this index, for the first index, I'll have to travel 1, 2, and 3. For the second index, you have to travel 1, 2. Third index 1, 2. So O of n square is the solution. O of n square is the time complexity, and space complexity becomes O of n. O of 1, sorry. Okay, O of 1. Okay, so how can I optimize this? Optimization. Okay, how can I optimize this? Basically, what I'll do is, if I'm given with this, okay, and my k is equal to 3, okay, what I can do is, if I could what are my cases? My ith element should be equal to the jth element, and absolute of I minus j should be less than equal to k, So so the first condition specifies that we have to look for only the equal numbers, okay, equal numbers, and I have to just compare it. I have to only compare it. So equal numbers can be stored. In a map. Suppose I make a map, and all the elements I'll just push into it. With their indexes. Okay. So if I try to push 1 with this index, it becomes 1, 0. If I try to push 2 with its index, I'll put 2, 1. If I try to push 3 with its index, I'll push 3 and 1, 3 and 2, and I'll push 1 again. So when I come to 1 again, it already knows that it has the element 1. So the first condition is automatically specified that the ith is equal to jth element. And for my second condition, I'll just check this index, and I'll check this index, and I'll check the index that is stored here. So 3 minus 0 becomes 3, that is less than equal to k. I'll return true. What is the actual thinking behind making a map? Because this can store all my elements, and if any of the element comes equal again, that is already stored. Okay, so I'll just compare the index. And store it. Okay, so this is my solution. So let us see this test case. Let us see the second test case that is given to us. 1, 2, 3, 1, 2, 3. Basically third in Leetcode. Okay, 1, 2, 3, 1, 2, 3, and k is equal to 2. So 1, 2, 3, 1, 2, 3. Okay, this is my array. And I'll write down its indexes 0, 1, 2, 3, 4, and 5. Okay, I'll make an unordered map. Okay, this is my map. Okay, so what I have to do is I'll simply traverse the array. I'll store it in my map. Okay, and whenever I get the same occurrence of the element that is present in the map, I'll just check the difference between the current index and the index stored in the map. If the difference is less than equal to k, I'll simply return true. Else, if I reach to the end of the array and still I didn't get any of this condition, I'll simply return false. So I come at the first index. Okay, I come here. Okay, I come here. my j is also here. Okay, so okay, I come here and I just start to iterate the array. I'll just start to iterate the array. So I come here, I come up to this index, come up to this index, okay, come to this index, okay, is one in my map? No, one is not in my map. I'll store the number with its index. So one is stored with 0. I'll come to 2. I'll come to 2. Is 2 stored in the map? No, I'll store it in my map with this index, obviously. I'll come to 3. I'll come to 3. Is 3 stored in my map? No, I'll store it in my map, okay, with its index. So this is my value and this is my index. This is my value and this is my index, okay. I come to 1. I check in the map. Is 1 present in the map? Yes, 1 is present in the map. So I'll just compare it with this index, okay. I have this index 3 and the index stored here is 0. So what is 3 minus 0? 3 minus 0 is 3, and what we are given, k less than equal to 2. K should be less than equal to 2, okay. K should be less than equal to 2. So does our condition satisfy? Is 3 less than equal to 2? No, no. I'll simply move forward. But I'll just make this updation. I'll just update the index. My index now will be 3. My index now will be 3. I come up to 2. I come to 2. I check it in the map if it is present. Okay, I check it in the map. Yes, 2 is present. 2 is present. I just check its index and I check the current index. Okay, so 4 minus 1 equal to 3. Is 3 less than equal to 2? No, no. So still my answer is false. I still didn't get any true. Okay, I didn't get any number that satisfies my condition. But I'll update this index. I'll update it to 4. Okay. I come to this index 3. Is 3 present in my map? Yes, 3 is present. I'll come up to 3. Okay. I'll take the current index 5. I'll take the current index 5. So 5 minus 2. This 2. Okay. So it becomes 3. Is 3 less than equal to 2? No. No. So as you can see, I have reached the end of the array. As I have reached the end of the array, and still I have not gotten any condition that satisfy my given conditions. Any numbers that satisfy my given numbers, my given condition. Okay. So at the last, I'll return false. At the last, I'll return false. This was the overall approach to the question. Okay. I'll just try to code it. Okay. So what I first need is, I first need an unordered map. Unordered map. Okay. Unordered map that will be storing int it. Okay, and what I'll do is I'll just iterate the whole array. I'll just iterate the whole array, and I'll just look for this number. I'll just look for the current number that I'm given with. So I'll just look for this number, nums of I. That is the current number, because the first condition is the number should be equal. So I'll look for this number. If it comes anywhere before in the array, okay, is not equal to mp.int, that means it is present in the array. Okay, and if it is present, I just have to compare if I minus mpp of nums of I, that is the condition. Okay, so I'll return true in this case. Okay, if these condition fails, I'll simply return false. And also I have to update my index every time I get a occurrence. So I'll just update my index, so it will be storing I. Okay, I'll just try to run it. Okay, I think there is okay. I'll try to submit. Okay, submitted successfully. Okay, so if I just try to tell you what I did in my code, I just declared a map, and every time I get the same number, I'll check the index that is stored in there. If the current index and the previous number difference, basically previous index, has a difference less than equal to k, I'll return true. Or if the loop ends, I'll return false. Okay, I'll return false at the end. Now, if I want to discuss its time complexity, I am just singly iterating. I'm doing it a single pass. So my time complexity for this comes as O of n. O of n. And what is my space complexity? As I'm using a map, so the space complexity is O of n. So this is my time and space complexity. I hope you like. So this was the overall solution of the question. Contains duplicate 2. If you guys have any doubts, you can just ping it down in the comments. And if you like the solution, do like, share, subscribe. Thank you. Have a nice day. Bye bye.